Hey PreCalc, it's May 1st, and I promised to put the rest of the answers up to this paper in case you were practicing on it. So we've already done number 1, 2, and 3 on last Thursday night's video, which you watched for Friday. So you can check back there if you want to see how those were done. But I haven't talked about this one. So if we have a 6-sided die that's rolled 6 times, what is the probability that the die will show an even number exactly twice, 2 times? So we're going to have 6 blanks above and below, and the 6 below have no restrictions, so it doesn't matter if they have an even or an odd number. So when you roll a 6-sided dice, there's 6 choices, 6 choices, 6, 6, 6, 6. They can be repeated when you roll a die, so it ends up 6 to the 6th on the bottom. So that comes out 6 to the 6th is 46,656. The top, we want 6 blanks. First 2 are even. The second part has 4 blanks, which are odd. So how many ways can we roll an even number? 3. How many ways can we roll an even number the second time? 3. How many ways can we roll an odd? They're 3, 3, and 3. So the only thing is there are different combinations of these. So we have to do combination of 6, taking 2 at a time, which is a 15. So multiply 15 times 3, 3, 3, 3, 3, 3, which gives you 10, 9, 35, and you can reduce or do the decimal. So that's number 4. Check that one off. On number 5, and I wouldn't look at this until you've tried it because it doesn't really help to watch me do it. So pause if you haven't done it yet. Alright, 9 true-false questions, and they're going to guess randomly. What's the probability that the student answers at least 2 questions correctly? So there's going to be 9 blanks. On the bottom, there's going to be 9, 9, 9, 9, I'm sorry, 2, 2, 2, 2, 2, 2. How many ways can you answer the first true-false question? 2. 2, 2, 2, 2, 2, 2, 2, 2, and 2 to the 9th. The top is going to look a little differently. We are going to have, first of all, the strategy for at least 2 questions correct means at least 2 means 2 correct, 3 correct, 4 correct, 5 correct, 6 correct, 7 correct, 8 correct, 9 correct, at least 2. So that's a pain to figure out each of those and add them together. It's easier to do the complement, which is 0 and 1. And we'll take it from 1. 1 minus the probability of 0 plus the probability of 1. So here I'm finding out the probability of 0. So what's the probability that they get all 9 wrong? So how many ways can you fill in the first true-false question with a wrong answer? 1. 1, 1, 1, 1, 1, 1, 1, 1. But how many combinations of these 9 answers taking 9 at a time? Another 1. So that comes up to 1 over 512. So that's this number here. Now we want the probability of getting 1 correct. So the bottom's the same, 2 to the 9th, but we are going to separate. We're going to have at least 2, so we're going to have the probability of getting 1 correct is, here I set it up, the probability of getting at least 1 correct. Alright, so I think I just put the wrong symbol here. Let's see if this still works. So these are all wrong and this is right. Probability of 1 correct. And so if these are all wrong, we will have a one way of filling it in incorrectly. One way, one way, one way, one way, one way, one way. And we get to the right answer. How many ways can we fill a true false answer incorrectly? One way. This time, however, we have a combination of 9 objects taking 8 at a time. Or perhaps you said 1 at a time. That will still give you the same answer of 9. So 9 times all these 1s over 512. So we're going to take 1 minus the sum of these. So 1 minus 10 over 512, which turns out to be 502 over 512, which is reducible, or you can use the decimal. So it's a high probability of getting at least 2 correct. Alright, so that one. Good. A basketball player has a 50% chance of making each free throw. This is going to be similar because it was 50% chance of getting a true-false question right or wrong. What is the probability that the player makes at least 11 out of 12 free throws? So at least 11 would mean the probability of getting 11 or 12. So that's not too hard to figure out. So we'll do each one and add it up. So the probability of getting 11, here's a correct, here's getting the shot, here's not getting the shot. So we have 12 blanks for the 12 shots, 11. How many ways can he get the shot correct? Well, there's one way. He's either going to get it or miss it. So there's one way of getting it in the basket. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And how many ways is it for him to not get a basket? 1. He either gets it or he doesn't. But we have the combinations of 12 things taken 11 at a time, which is 12. So we end up with the 12 times all these 1s divided by, on the bottom, how many different ways can he get the shot? He can get it or not get it. There's 2 ways for each blank. So with no restrictions, he can get it or not. So there's 12 blanks. They each have a 2 in them, 2 to the 12th. So that's the probability of getting 11. The probability of getting 12 is all 1s. These are all shots that he got. And the combination of 12, taking 12 at a time, is also a 1. So we get 1 over 2 to the 12th. So we're going to add those two, and that'll be our answer. And here's the decimal form. All right. Is there any on the back we haven't done? We already did this one with the fireworks in class, and here's the work for that. And we already did the black and brown buttons. Here's the work for that. And I don't think we've done this one yet. So you're dealt 5 cards. Note that a standard deck is 52. What's the probability you'll have at most 3 kings in your hand? At most 3 means you want the probability of 1, 2, or 3. But not 4. So let's make it simpler and do 1 minus the probability of 4. So we're going to start out figuring out the probability of 4. And the probability of 4, we got 5 blanks. The first 4 have to be kings. So how many ways can you draw a king from a deck? Well, there are 4 kings. So you have 4 and then 3, 2, and 1. And not kings. So everything that's not a king is 4 from 52, which is 48 ways. And then you have the combinations, 5 objects 4 at a time, and that gives me a 5. 5, 4, 3, 2, 1, 48 multiplies to 5760. On the bottom we have 5 blanks, but we can fill them out 52, 51, 50, 49, 48 with no restrictions, which comes out to this number in the millions, and it reduces to a small number, but I took it from 1 and got a large probability. All right, and here is the bag with 6 real. We already did this one. Yes, we did. So this one was at most 4. So we found the probability of 5 and 6 and subtracting that from 1, which was easier than doing 0, 1, 2, 3, and 4 and adding them up. So there's the probability of 5, here's the probability of 6. We added them together and subtracted from 1, and we did that one together earlier. Alright, so I hope that you are studying these things for the test so that you can do well. Carry on.